Have you ever wondered how things change over time in mathematics? How do mathematicians measure the rate at which something is changing at a particular moment? Well, the answer to these questions lies in a concept called derivatives. A derivative, in its most basic form, is a measure of how a function changes as its input changes. Think of it as the mathematical equivalent of a speedometer in a car. Just as a speedometer measures the speed of a car at a particular moment, a derivative measures the rate of change of a function at a particular point. Now, how do we calculate a derivative? The formula we use is called the limit definition of the derivative. It might sound complicated, but it's really just a precise way of finding the rate of change of a function. In this formula, we calculate the difference quotient, which is the average rate of change of the function over a very small interval. As we make this interval smaller and smaller, the difference quotient gets closer and closer to the instantaneous rate of change of the function. This is the essence of the limit definition of the derivative. Let's consider a few examples. If we have a function fx equals x squared, its derivative is 2 times x. If we have a function jur x equals sine of x, its derivative is cosine of x. And if we have a function hx equals e to the power of x, its derivative is still e to the power of x. But why are derivatives so important? Well, they have a wide range of applications. They can help us find the maximum or minimum value of a function, determine the velocity and acceleration of an object, find the slope of a tangent line to a graph, and even measure the rate of change of a function over time. In short, derivatives are a fundamental tool in calculus, and they play a crucial role in fields as diverse as physics, engineering, and economics. They help us understand and predict how things change over time, making them an indispensable tool in the mathematical toolkit.